Today I'm going to show how to build an assembly in Onshape using mates and mate connectors. I'm going to be doing this using the Vex ecosystem. To get started, I need to install this Vex library. I did that by just Googling Vex library Onshape. And the first result, the Vex V5 parts library, should have everything you need. You'll need to subscribe to it and then refresh your Vex window, your Onshape window, in order to use it. Now, the first thing I want to do is I made this new document that has a part studio and an assembly. One maybe unfortunate thing about Onshape is it does not support part mirroring, so you have to do oftentimes more mates than you would on SolidWorks, but it's not that bad. And I'll show you the basics of how to do this, hopefully relatively fast. Going over to the Vex library, I'm going to start by inserting a U channel. This will be my cross piece of my robot. And going in here, I'll go down to structure and or a C channel rather, and I'll put in a 16. Oh, come back. I'll put in a, let's say, 16-inch C channel, and I'll do the 1x5 aluminum. When you hit Insert Part Studio, it's going to take a while to show up. So just give it some time. Don't click it multiple times. All right, so this is my U channel here. I would like my robot to actually match my top front right here. So I am going to try to position this U channel so that at least it's going left to right, even if it's not perfectly centered. So the first thing I'm going to do is I'm going to rotate it here, grabbing that little icon there. All right, so that's 90 degrees. Great. And I would like to place this perfectly in the middle. So I'm going to try adding a mate connector up here. And so what a mate connector is it allows us to attach a part in a particular orientation. So on here as well, if you hover over here, you can see a list of all the mate connectors that or all the places basically that you could attach to. Notice if I try to go in the middle of one of these squares, it disappears. And the way to get around that is I'm going to hold down the Shift key, and then that will let me select in the middle here. You'll also see a white and black little circle here. That's the center of mass, and that's what I'm going to select for the center of my robot. So I will select that, and I'm going to note that the red is pointing forward, the blue is pointing up, and the green is pointing left. All right, to confirm this, I need to hit the check mark. Next up on my origin here, I'm also going to place a mate connector, and I'm going to place it in the exact same orientation as over here. So we can see that that is a little bit different. I'll go ahead and click on here. I'm going to try reorienting the axis here. You see how that is rotating it by 90 degrees. And I'm clicking that until that lines up perfectly with this mate connector. That means when I combine these, it's going to lock exactly into that spot. And then making sure to click the green check mark to confirm. I always forget that. All right, so here I'm going to do a fastened mate now with the M key, or clicking that icon. You're going to want to select two mate connectors. I'll select my first one here, my second one here, hit the check mark. All right, and my, my box channel is perfectly locked in the middle. All right, I'm going to add my other C channel or U channel. Can't remember what the difference is. C channel on the side here, and then I'll add another one over on the other side. So moving on here, looks good. I'm going to add a 1x3 now. And just like I did before, before I start adding any mates, I'm going to rotate this piece. So I'm going to exit this mode, select my piece, and I'm going to just get it in the general area that I want it before I start adding any mates. So moving over here. All right, so I'm going to do a different selection this time, or a different technique this time. Instead of adding mate connectors, I'm going to do more of the SolidWorks way of adding 3 mates in order to lock this into place. I will start by doing maybe this 6th hole here to the 1st hole here, and I'll show you how this is done. So now instead of adding a mate connector, I'm just going to go straight into these mates here. There's a lot of different ones. The ones that I use most often are planar mate, cylindrical mate, and parallel mate. And I'll show you them, and then I'll show you some problems that you might run into with these. So first up, I would like to attach this bottom plane here and stick that coincident to this plane here. To do that, I'm going to use the planar mate. And for this case, I can just select anywhere on here. I'm just going to click on the flat area here. And then I'm going to click on the flat area here. It'll move it over here. That's okay for now. All right, and I can just see visually that that's all looks good, so I'll hit the check mark. All right, up next I'm going to do this hole to this hole. Now because this is a not actually a hole, it can be hard to find the center, but as I talked about earlier, if you hold down the shift key, it will reveal the all of the potential points that you can use. So this mate is going to be a cylindrical mate, even though this is not a cylinder. I'm going to hold down shift and select that hole right there. Come over here, I'm going to hold down shift and select that hole right there. It's going to move it where it thinks it is. You'll see that now it's ignoring the planar mate and it's actually phasing through that material there. And what you're going to want to do before you hit the check mark is hit solve, where this will apply all of the mates, including the ones you did before, and hit the check mark here. So that's a cylindrical mate. You'll see that that still allows this to rotate freely. What I'm going to add now is a parallel mate to lock this into place here. So I'm going to add this parallel mate. And I can go ahead and click here and here. You can see that it phased it again, so I'm going to hit solve, and that is all good here. You can see I could add limits here, where instead of being perfectly parallel, I could say it's between 30 and negative 30 degrees or something like that, if I wanted to model motion in the assembly. For now, I'm just going to leave it with no limits. Hit the solve button, hit the green check mark, and we are good to go. So that was a more SolidWorks approach to adding a mate. I'm going to do the other side with a mate connector as well. So going back over here to the structure C. All right, and like before, I'm going to select this. I'm going to rotate it into place. So I have to do less thinking here. All right, and I'm going to try to do this with the mate connectors. This is more of the Onshape way. My first hole here, I don't want to select this top here because I want these to be in the same point in space. So I'm going to try selecting the bottom here, holding down shift to keep those holes locked in place, and clicking here. Now all my other ones, the blue was pointing up, the z-axis was pointing up, so I'm going to hit this flip primary axis here to bring that more in line with everything else. and I have my red pointing forward, my green pointing right. So I have to remember to do that on my mate here. I'm going to hit this mate connector again, add one here. All right, and these are not lined up, so I'm going to keep hitting this reorient primary axis until they are. There we go, red forward, green to the side, blue up. Looks good. All right, and I'm going to do a fastened mate now between this mate connector and this mate connector. Hit solve. Check mark. All right, that looks pretty good to me. So I'm pretty happy with that. All right, I'm going to show you another example of maybe why you might want to stay away from using parallel mates. They can be useful sometimes, but they can be frustrating other times. Let's go to, I'm going to look for a, what is it, bushing? No, I guess a bearing block. All right, so I'm going to add in this low profile bearing, flat bearing with screws. I'll just do the default configuration here. All right, and I'm just going to add this over here. I'm going to move it kind of where I want it first. All right, and check this out. So I'm going to add in, I'll do it the same way I did the other way. I'll do a planar mate between here and here. Looks good, check mark. I'll do a cylindrical mate between this bolt and this hole over here. All right, and then because this can still move around, I'll do a planar mate, or parallel mate rather, between this top here and this top here. Hit the solve button. All right, everything looks good. Right, I have my three mates here. Something to note, I should have mentioned before, is how to tell if a part is locked into place, and I'll show you that real quickly. I'm going to add a flat bearing with screws now. And you can see when I add this part in, over here it has these three arrows, which means it has degrees of freedom, which means it is not mated completely. If you are just building your frame like this and you're not working with mechanisms, everything should have no degrees of freedom. Anyways, this part, as you can see, has no degrees of freedom, so that means it's nicely added in. And let me show you the problem with parallel mates now that might sneak up on you. I'm going to try the same thing I did with the other bearing. I will do a planar mate between here and here. All right, and I'm going to do a cylindrical mate between here and holding down shift here again, here. I'm going to hit solve to apply both of those mates. And then finally, I'm going to do my parallel mate between here and here. Hit the solve button. You can see that made all three of my mates red, meaning that mate is impossible. So what's going on here, and it's actually, this is correct. I can't do this mate. I'll show you what's going on by clicking the front here. And if we zoom in, you'll see that actually these bearings are not perfectly flat. And this is true for a lot of the models and CADs that you'll use. It's because maybe the way that they were injection molded or whatnot, they are not actually parallel. So this would be a great place to use a mate connector You could also get away here with using a, I'm going to do another cylindrical mate between this round part, and I guess I need to move this out of the way first. Then I'll do a cylindrical mate between here, here, solve, check mark. All right, so that's the basics of adding mates.